On October 29th, the interstellar object 3I Atlas reached perihelion, its most critical moment, completely hidden behind the Sun. This 5-kilometer behemoth defies all physics. It carries 8 statistical anomalies, from an impossible anti-tail to a composition that matches industrial alloys. The combined odds of it being natural are less than 1 in 10 quadrillion. The world's radio telescopes are listening for the signal that proves we are not alone. A third interstellar visitor to our solar system just reached its closest approach to the Sun at exactly 7:47 a.m. Eastern Time on October 29th, 2025. But astronomers cannot see what happened because it's hidden behind our star at this critical moment. The object, designated 3I Atlas, carries 8 statistical anomalies so improbable that their combined odds are less than 1 in 10 quadrillion, leading Harvard astrophysicist Avi Loeb to classify it with a score of 4 on his scale, where 0 means definitely natural and 10 means definitely technological. This 5-kilometer wide object dwarfs our previous interstellar visitors by extraordinary margins. It measures 1 million times more massive than Oumuamua and 1,000 times larger than 2 Hus-I Borisov. To grasp its scale, our largest rocket, the Starship, would fit into Atlas 100 times over. Yet despite this enormous size, Atlas moves faster through space than similar massive objects should, a combination that occurs naturally less than 0.1% of the time. The timing precision of Atlas creates the most striking pattern. JPL Horizons calculated its perihelion passage with accuracy down to just a few minutes, placing the object behind the Sun precisely when it experiences its most intense heating at 770 watts per square meter. This same trajectory brings it close to Mars, Venus, and Jupiter in perfect sequence, while keeping it hidden from Earth during perihelion. The probability of this specific timing arrangement happening by chance measures just 0.005%. Radio observers worldwide have mobilized for continuous monitoring following recent revelations about the object's anomalies. Congresswoman Anna Paulina Luna is actively working to release high-resolution images from October 2nd, 2025 to the scientific community. Scientists search for specific signals, including deliberate maneuvers, release of mini-probes, radio transmissions, artificial lights, or excess heat from possible engines. If Atlas fragments from natural causes, the intense perihelion heating would create a much brighter plume of gas and dust visible as cosmic fireworks. The first anomaly involves its orbital alignment. Atlas travels just 5 degrees from the ecliptic plane where all planets orbit, with only 0.2% probability for a random interstellar object. Objects arriving from deep interstellar space should show no preference for our solar system's specific orientation. The ecliptic plane exists as a local feature of our system that distant objects would have no reason to match. This precise alignment appears as if the object had been deliberately directed to follow the gravitational highways of our solar neighborhood. The second anomaly defies fundamental cometary physics. During July and August 2025, Atlas exhibited a jet directed toward our star, an anti-tail behavior never observed in natural comets. Every comet humans have studied develops tails pointing away from the Sun due to solar radiation pressure, a basic physical law governing these objects. Atlas did the opposite, creating a jet aimed straight at our star. This behavior suggests some type of active propulsion or internal mechanism that contradicts all known natural processes for cometary activity. A missed opportunity haunts astronomers studying this object. Loeb calculated that if Earth occupied the opposite side of its orbit, where it was 6 months ago, or will be in 6 months, we could have mapped Atlas with radar systems. In that hypothetical position, the object would have passed just 54 million kilometers from Earth, close enough for existing radar systems to detect and image it. This would have provided direct measurements of its size and three-dimensional images of its shape through multiple captures during its 16.2-hour rotation period. Unfortunately, even at Earth's closest approach on December 19, 2025, the distance of 269 million kilometers makes radar detection unfeasible. Current technology cannot bridge that gap, leaving astronomers dependent on optical and radio observations. The object will remain too distant for the detailed structural analysis that radar would have provided, forcing scientists to rely on indirect methods to understand its nature. The chemical composition presents the fifth major anomaly. The gaseous plume contains much more nickel than iron, matching artificially produced industrial alloys with less than 1% probability of natural occurrence. This metal proportion characterizes terrestrial industrial processes, not natural cosmic formation. The nickel to cyanide ratio exceeds any known comet by orders of magnitude, including 2 I Borisov. These compositional signatures suggest processed or refined materials, rather than the random mixture expected from natural objects forming in stellar systems. Water makes up only 4% of Atlas by mass, contrasting dramatically with typical comets that consist mostly of ice. Comets are fundamentally dirty snowballs composed of 80 to 90% water ice, a definition that applies to every comet studied in our solar system. Atlas challenges this basic understanding by being almost completely devoid of the most fundamental component of comets. This dry composition aligns more closely with metallic asteroids or artificial structures than with any natural comet observed before. The seventh anomaly involves unprecedented optical properties. Atlas showed extreme negative polarization never recorded in any known comet, including 2 I Borisov. Light polarization from reflected sunlight reveals fundamental surface properties of an object, providing information about grain size, composition, and structure. No natural comet has ever exhibited this specific type of optical signature. This unique characteristic indicates a surface or internal structure completely different from any known cometary material in our databases. The eighth anomaly connects Atlas to one of astronomy's greatest mysteries. The object arrived from the direction of the famous WOW signal with 9-degree precision, a probability of just 0.6%. The WOW signal, detected in 1977, remains the most mysterious and potentially artificial radio transmission ever recorded. The directional correlation between Atlas and this historical source exceeds random chance by a significant margin. This alignment suggests a possible connection between two phenomena that have challenged conventional astronomical explanations. Loeb emphasizes that we must collect as much data as possible to discover the nature of this anomalous object. The implications of alien technology would be enormous, requiring serious consideration of this possibility. If Atlas proves technological, its creators master capabilities extending far beyond our current technologies, including precise interstellar navigation and possibly active propulsion systems that operate across cosmic distances. The statistical impossibility of these combined anomalies demands explanation. Multiplying the individual probabilities of each anomaly occurring naturally produces odds of less than 1 part in 10 quadrillion. This number represents such a small chance that it defies any explanation based on coincidence or random occurrence. Each anomaly alone might be dismissed as unusual but possible. Together, they form a pattern that challenges our understanding of what natural objects should look like. Scientists now watch for specific technological signatures as Atlas emerges from behind the Sun. Any deliberate maneuvers would immediately identify it as artificial. The release of mini-probes would confirm a technological origin beyond doubt. Radio transmissions or artificial lights would provide direct evidence of non-natural systems. Excess heat beyond what solar heating produces could indicate an engine or power source operating within the object. Natural explanations remain under investigation despite the anomalies. If Atlas consists of loosely bound material held together by weak forces, the intense perihelion heating might fragment it into multiple pieces. This breakup would create a dramatic increase in surface area, producing a much brighter plume of gas and dust visible to telescopes. Such fragmentation commonly occurs with natural comets passing close to the Sun, though Atlas has already survived closer than many comets that broke apart at greater distances. The timing of perihelion passage creates a unique scientific tension. Precisely when the object experiences maximum stress from solar heating at 770 watts per square meter, terrestrial telescopes cannot observe it. This blindness occurs at the most critical moment for determining whether Atlas behaves like a natural comet under extreme conditions or demonstrates technological resilience. By the time it emerges from solar conjunction, any perihelion-induced changes will have already occurred. The object's massive size compared to previous interstellar visitors raises fundamental questions about detection bias. Oumuamua measured roughly 100 meters across, 2 I Borisov spanned about 500 meters, and now Atlas extends 5 kilometers. This progression might indicate we're only detecting the largest members of a vast population of interstellar objects passing through our solar system. Alternatively, Atlas might represent something fundamentally different from its smaller predecessors. The alignment with our ecliptic plane becomes more significant when considering interstellar trajectories. Objects ejected from other star systems should arrive from random directions, reflecting the chaotic dynamics of stellar encounters. The galactic disk itself shows no preferred orientation relative to our solar system. For Atlas to arrive within 5 degrees of our planetary plane suggests either an extraordinary coincidence or a deliberate choice of approach vector. The anti-tail phenomenon observed in July and August 2025 contradicts every model of cometary behavior. Solar radiation pressure and solar wind always push material away from the Sun, creating tails that stream behind comets like flags in stellar wind. Atlas produced a jet aimed directly at our star, requiring either internal pressure exceeding solar forces or active propulsion countering natural physics. No combination of ice sublimation, dust emission, or gas release explains this behavior within current cometary science. The nickel-rich composition points toward industrial processing, if artificial, or an entirely unknown natural formation process, if not. Nickel-iron ratios in natural meteorites and comets follow predictable patterns based on stellar nucleosynthesis and planetary differentiation. Atlas breaks these patterns with nickel abundance resembling engineered alloys more than cosmic materials. The extreme nickel to cyanide ratio amplifies this mystery, exceeding anything measured in our solar system or from 2 I Borisov. The near absence of water ice challenges the fundamental definition of a comet. Without significant ice, Atlas cannot produce gas through sublimation the way normal comets do. Yet it displays cometary activity, including the controversial anti-tail. This paradox suggests either a completely different mechanism for producing gas and dust, or that our detection methods are missing something fundamental about its composition. The 4% water content might exist as deeply buried ice or chemically bound water rather than the surface ice typical of comets. Extreme negative polarization provides another piece of the puzzle. This optical signature could result from unusual grain properties, exotic surface materials, or internal structure, unlike anything in our solar system. Laboratory experiments struggle to reproduce this polarization using known materials. The measurement stands so far outside normal cometry values that instrument error was initially suspected, but multiple observations confirmed the reading.